Welcome to Frontline Systems webinar on an overview of optimization applications in Excel using our advanced products. My name is Dr. Sima Maliki. I'm Consulting Lead and Modeling Specialist at Frontline Solvers. During this presentation, if you have any questions or comments, please type them into the chat box to be answered at the end as time allows. I strive to remain within the promised 30 minutes, yet to thoroughly cover all the material, sometimes it takes a few minutes longer. I very much appreciate your cooperation. And also, we have assigned a specific number for your needs, and at the end, I will share that number with you so you can directly call Dwayne to answer any of your questions. As we all know, the optimization applications are widely used across many industries and functional areas. We'd like you to know that many of our customers have found optimal solutions for their industrial problems worth millions in savings, as building a model can give you insights and a money-saving optimal solution. Today, we explore how optimization can benefit you in solving your business problems and how easy it is to use our tools to solve them. Together, we'll review typical applications in transportation, inventory management, financial services, scheduling staff, and one example of automating optimization using VBA. Maybe you wonder what solvers are good for. So let's start talking about the decision-making process and using optimization to solve a problem. It is always best and most powerful to efficiently allocate scarce resources arising in your business. It can be money, equipment, staff time, transportation fleet, or raw materials inventory. All of these are resources and they are allocated for some purpose. Deciding on which products to ship from factories to warehouses along each route is an allocation of products to routes. Portfolio optimization is allocating money to stocks in a portfolio, and scheduling is really a matter of allocating people to time slots or scheduling the availability of hospital operating rooms. Solvers or optimizers are software tools that help you determine the best way to allocate those resources. You might be wondering what you need to do to use a solver or how to define your optimization model. Let's drill down on this further. There are three main steps. Each optimization problem involves one or more decisions that must be made in order to solve the problem. The decision variables are typically numbers reflecting how much of some scarce resource is being allocated to some use or purpose, and that is normally under your control. These decisions need to be made in the best possible way while simultaneously satisfying a number of logical constraints or conditions. Constraints reflect the physical situation, and there are various types of them. Some of them, for example, represent limits on available resources such as inventory or money. There are constraints that reflect the physical situation. One of them is the non-negativity on variables. You cannot produce a negative number of products, and you cannot assign a negative number of people to tasks. Some constraints are determined by policies that you or your organization may set. For example, in a portfolio optimization, you might have a limit on the maximum percentage of funds to be invested in any one stock or one industry group. Then you might have balance constraints. For example, warehouses are temporary holding points. Therefore, flow out from one warehouse is equal to its flow in. They have an equality form. Or the beginning inventory of this cycle equals the ending inventory of last cycle. Another common element in each optimization problem is the existence of some goal or objective that the decision maker considers when deciding which course of action is best. You can determine objective function by asking what measures are we trying to optimize. The best or optimal solution might mean maximizing profits, minimizing costs, or achieving the best possible quality. Now it is time to dive in and see how we can solve a problem in practice. Transportation and logistics operations of your company can be a competitive differentiator. So let's find out in this example how optimization can be used to optimize a transportation operation. This company has 3 different goods that have to be shipped from 2 factories to 4 warehouses, and from those warehouses to the 5 customers, or even directly from factories to the customers with minimum cost. This is a diagram of the system with nodes for factories, warehouses, and customers. Now, we need to show the supply-demand pairs displaying feasible routes for the shipment plan. These gold-colored arrows show the potential flows from factories to warehouses and customers, and these green arrows show the potential flows from warehouses to customers. Now, let's take a look at the Excel workbook, which is ready for us. As you can see, this is the full analytics solver platform ribbon, which includes optimization, simulation, and data mining. Today, we are going to focus on a subset of analytics solver platform called Premium Solver Platform, so we can change the product. And I'm going to show you how, because when you're using a free trial of our software, you can do this yourself. So let's click on Help, Change Product, and here, instead of Analytics Solver Platform, let's choose Premium Solver Platform, click OK. Let's click on Premium Solver Platform ribbon. As you can see, now we only have access to optimization. Let me adjust the size so I increase the size of this Excel workbook. Now, let's skim through the Premium Solver Platform ribbon together. As you can see, if I click on this Model tab, the task pane will be displayed or hides. And there is a drop-down here in this Model tab. There are additional options for multi-dimensional modeling that are beyond the scope here, but you can explore them and use our user guide to learn more about dimensional modeling. Then we have the Optimization Model tab that allows you to set up optimization model, including decisions, constraints, and objective. And we'll practice this today. Parameters tab provides the options for you to run multiple parameterized optimization, and again, we will practice this today too. Solve Action tab allows you to solve optimization models. Here on the Analysis tab, you can analyze the results, create reports and charts. Tools tab enables you to examine optimization results. Furthermore, you can see this Publish button that allows you to publish your models for use and distribution on the web. We have the Solver app available on Excel Online and also on Google Sheets, and it's free. Now let's look at the Help tab. Here you can display online help, use live chat, control guided mode, which we'll discuss in more detail today, open examples or an online tutorial, access user and reference guide, and check your license status and more. So as we just saw, clicking on the Model tab displays or hides this task pane. So let's briefly check it out. The Model tab allows you to view the model in outline form. You can see the results of my model diagnosis and optionally edit model elements in place. Then you can see there is the Platform tab. Here you can view or change the platform options, such as the number of optimizations or the default bound on decision or uncertain variables. Then we have the Engine tab. Here you can select a solver engine and set its options. And finally, we have the Output tab that allows you to view a log of solution messages or a chart of the objective value. So now let's go back to our example. As you can see here in this Excel workbook, the cost of shipping from factories to warehouses, factories to customers directly, and from warehouses to customers are recorded in these cells. These are inputs to the problem that are not under our control. These shipping costs are coded for us by our outside shipping company, for example. However, what is under our control are decisions about how much to ship along each route at these different locations. So, we need to reserve cells for variables representing quantity shipped from factories to warehouses, from factories to customers directly, and also from warehouses to customers. This is how we define decision variables. As you can see here in this Model tab of TaskBin, 3 sets of variables are defined. Now, what measure are we trying to optimize? Each route of flow incurs a cost. There are two goals that need to be carefully addressed in this problem, the total costs and the service. We want to provide the service with minimum cost and ensure that each customer demand is completely satisfied. So, our objective function is minimization of total cost of shipment. And total cost of shipment along all the routes. This objective function, if I double click, is defined in cell C91. And let's say close this so I can show you the formula of this cell. Okay. This is represented by a sum product function. Let's look at the first component. To calculate total cost of shipping from factories to warehouses, since the cost coefficient for these routes are defined in cell C10 through F15, we need to multiply these by total amount of the product that will be determined to be shipped, our decision variables for which we have reserved cells C41 through F46. And similarly, we need to add the other costs. Now on to constraints. What restrictions limit our choice of decision variables? The capacity of each warehouse, supplies available from each factory, and the demand from each customer need to be considered. So, first constraint, warehouse capacity constraint. We want to make sure that what we ship into the warehouses doesn't exceed the capacity of those warehouses. We cannot overload warehouses as each one has a physical capacity. Then we have a certain supply available at each factory provided in cells H63 through H68. Let me move this so you can better see this. The total flow out of factory 1 for each product type must be smaller than or equal to the factory supply. And this is the same for factory 2 and so on. Flow out from one warehouse is equal to its flow in.
Muted.
These types of constraints are called balance constraints. Let me double click. Oh, excuse me for this one. Okay. As you can see, they have an equality form. Okay. For now, let's go ahead and solve the model by clicking Optimize button on the ribbon. This time, we are going to step our way through guided mode and see what it can tell us. This feature is a guide offering help for you in each step of your modeling efforts, preventing common errors. Let's click on Continue. Two things happen here. First, Solver has analyzed all the formulas in this model and determined the structure of our model automatically. It's a LP or linear programming convex. Because I didn't choose the right solver engine, it is letting me know and giving me another choice. So I am going to choose the right engine that is offered, and then so it is telling me to choose standard LP quadratic, and then click on next step. Now guided mode tells us that solver found the solution, all constraints and optimality conditions are satisfied. Let's click OK, and now we are back to where we were without the guided mode. Here is the solution. We achieved what we wanted here, which was to determine how best to ship products between the factories and warehouses and customers, so to minimize our shipping cost, which is now excuse me, $519,700. Excuse me. After you have used guided mode for a while and you're solving over and over, you might want to get rid of these dialogues that you have to click through every time. So let me show you how you can actually do this. So click on Help and then Operating Mode. You can see that you have three options. And here, instead of using the Expert mode, we recommend you to choose Auto Help mode, which will only bring up the dialogues when there is a problem. But for this practice today, let's keep the guided mode. So we just looked at how optimization can help us with a typical transportation problem. Next, let's look at an inventory management example. Let me bring the example. Okay. This warehouse sells 4 products with a different demand for each product. Each product has a different holding cost and requires a certain amount of space. We have a limited storage capacity. So, what is the best ordering policy for a warehouse to minimize cost while meeting demands? As you might know, there is an analytical solution for this problem, which is known as economic order quantity, or EOQ. Unfortunately, this formula doesn't always work in real world. Demand usually fluctuates, order time is variable, and other factors arise to further complicate the problem. In this model, we have one such factor, a limited storage space. The variables are the amounts to order each month for each product. These are defined as quantities, as you can see right now. By changing these variables, we change the total cost. Let's close this. And then our constraint. We have the storage capacity constraint. So our space used is less than or equal to the available space. If this storage limit wasn't present, the solution to the problem could be calculated by economic order quantity formula. But here we are using optimization to solve a problem in a more complicated situation. Now let's look at the objective. Here our objective is to minimize the total cost. And it's defined in E17. So let's look at the formula. And this is the total cost for all the products. And these costs are calculated by using the formula holding cost times average inventory level plus the cost to place an order times average number of orders. And actually, let me show you one of these formulas. And this is a nonlinear problem. Let's actually click on Optimize and use guided mode to tell us this information. Let's click on Continue. It is telling us that this model was diagnosed as a nonlinear problem, non-convex. Let's click on Next Step. And here it is telling us that solver found the solution. Let's click on OK. And here are the results, which are amounts to order each month, minimizing cost, meeting demand, and without exceeding the storage space. Now, on to our example in a financial services application, allocating money to stocks. An investor wants to target a specific rate of return for his portfolio while minimizing risk. This is a portfolio optimization application. So the goal is to find the best combination of stocks that minimizes risk for a given return. The returns and variables and covariances between all stocks are known. In order to save time, I have already organized the data and created the formulas on the spreadsheet. So let me bring it up. And okay, here's the workbook. In this problem, the variables are the percentage allocations of the funds that we can invest in each stock. Let's define the decision variables using the ribbon. As you can see in the model tab, there's no optimization model defined. Now we can reserve cells C14 through G14 to hold the percentage allocations of the funds or the decision variables. So select those cells. You want to make sure Premium Solver tab is active, and then click Decisions to define these as our normal decision variables. And you can see I use name ranges, and you can see allocations or C14 through G14 are now added in the Model tab. To define the objective, the portfolio variance, I have defined a quadratic function in cell C18 to calculate the portfolio variance by a custom quad product function. So let's click on Escape. Select this cell, and now go to Objective and choose Minimize to define C18 as a normal objective to be minimized. And then we have two constraints. The first constraint is the total portfolio constraint, summing the allocations of funds to stocks, which is summing to 100% or 1. We need to set up one cell in the spreadsheet to represent the formulas of this constraint. Here I have used H14. You can see it's the sum of the allocations. Now let's use our mouse to select this cell on the worksheet, then click on Constraints and click on first constraint button, and then choose Equality. Now to define, our H14 is our left-hand side. I use the name range, a total portfolio. Now at the right-hand side, I will just click Enter or enter 1 or 100%. Now click on OK. Our second constraint is total portfolio return, and we want to make sure it is greater than 9.5%. So we need to reserve one cell in a spreadsheet to represent this formula for this constraint. Here I use cell C20. Use your mouse, select this cell on the worksheet, then click the Constraints, Constraint, and then let's choose greater than or equal to sign to define C20 as the left-hand side. Now in this Add Constraint dialog, we can enter 9.5% and click OK. Now you can see our constraint. Both of them are added to the Model tab of the task pane. Let me show you how the Output tab works. So let's hit this Optimize. I'm going to skip Guidance, and here are the results. The allocations of funds to different stocks, which resulted in the minimum risk or minimum variance portfolio and achieved 9.5% return. This is often called an efficient portfolio. You may have heard of the efficient frontier. Using Premium Solver platform, you can construct that efficient frontier rather easily, and I would like to show you how you can do it. So far, in this example, we have used the solver and found the optimal portfolio with minimum variance for a given target rate of return of 9.5%. Now, let's generalize that. We can utilize parametric optimization to find the efficient frontier that is the optimal solution for several levels of portfolio return. To do this, let's choose one empty cell, for example, D20. Now click on Parameters and then choose Optimization to insert this parameter. This dialog box will open. Now we can input 8% for the lower level and 14% for the upper level, as one of our stocks returns 14%. Let's click on OK. You can see this parameter is added in the Model tab. Now we have to modify the constraint right-hand side to point to this parametric return rate. Let's double-click on Portfolio Return Constraint. Now, instead of 9.5%, I want to point to this parametric return rate cell D20. Let's click on OK. Next thing we need to do is to change the number of optimizations. So let's click on Platform tab. Here the first option is optimizations to run. This is 1, and I would like to change it to 10 for this practice. Okay, let me clear the Output tab. Okay, now let's click on Optimize, and I'm going to skip guidance. You can see 10 optimizations are finished. The worksheet will initially display values for the last optimization, but we can display any of the optimization results by changing the selection in the optimization number in the ribbon. So you can see this is optimization 10. I can go to optimization 1, the results get updated, and then I can go to optimization 3 and so on. Now, let's explore charts. Click on Charts, Multiple Optimizations, and then let's choose Monitor Cells. Let's choose Portfolio Variance, our objective, and click OK. This is the efficient frontier plot. And you can click on this button on the right side and open the right pane. These are chart options. Let's go to chart options. You have access to different chart type, access options, and in chart options, you can change the X coordinate. Here it is optimization index. We ran 10 optimization. I want to change it to our parameter. We can see that, so we can see the return threshold. Okay, let's close this. Now, a recap on what we practiced: modeling and solving problems in Excel spreadsheets. You can reserve a cell to hold the value of each decision variable. You can pick a cell to represent the objective function and enter a formula that calculates the objective function value in this cell. And you can pick other cells and use them to enter the formulas that calculate the left-hand sides of the constraints. The right-hand side can be entered as numbers in other cells or entered directly in the solver's Add Constraint dialog. And one quick note, it is best practice to use constants for constraints right-hand sides. Now, let's look at some scheduling examples. This example is about allocating staff, something that you might, some kind of problem that happens a lot, and you might find it very useful. An amusement park needs a certain number of employees each day of the week. Every employee must be on a schedule that gives him or her 2 consecutive days off. How many employees should the park hire, and what schedule should they be on to minimize total payroll cost? Let me open the Excel workbook. Okay, here is the model. So for our employees working five consecutive days with 2 days off, we are looking to find the schedule which meets demand from attendance levels while minimizing payroll cost. So we have 7 possible schedules, and you can see them here, A through G. Decision variables reflect the number of people hired for each of the 7 possible schedules. Let me double click so you can see employees per schedule. And as you can see, they are defined as integer variables. And then our logical constraint, the demand. And we want to make sure employees per day is greater than or equal to required employee per day. Now, let's click on Optimize to solve this problem. Oh, just before that, let me actually go to Objective and run this again. So I'm going to stop this, go back to Model tab, Payroll. We want to minimize our payroll, and I'm going to show you how we have defined this function is total schedule and then the cost per employee per day. Now let's click on Optimize, click on Continue. Our model is LP and mixed integer programming. Next step, and here are the results. So we know what is the number of required people for each schedule. Now, there is a second version of this problem, or the next step in this decision scheduling problem. Let me show you that. The park has hired the required employees. It now needs to decide which employee goes on which schedule. Each employee has given a list with his or her preferences. A 7 means the most desired schedule, and a 1 means the least desired. How should the park divide the schedules among the employees? These schedules are binary, and each employee can be allocated to only one of the schedules. Here are the decision variables. Binary, they are defined as binary here. Now let me increase the size. Then the constraints, employee schedule should be equal to employee required. That we came out with this in the previous problem. And then a schedule per employee should be 1. And this is just a sum over all schedule assigned to one person. So we just want to make sure each person only gets assigned to one schedule. And then our objective is to maximize total preferences. So let me show you how we have defined this function. This is the sum of all preferences for all employees. And then let's look at one of these preferences function. So it's a sum product of employees' preferences times the schedule assigned to that employee. So let's click on Optimize. Let's skip the guidance, and here are the results. In this model, we solve the problem after finding the optimal solution of scheduling 1. It is also possible to find both solutions automatically. You can write a VBA macro to do this. Now, it is a good time actually to talk about automating your models. This allows you to run your predefined solver models and control the solver. You can automatically update data, run the model, and retrieve the results, and also create an application to distribute to your end users. You can automate your models and control solver engine using VBA Object-Oriented API. I want to actually show you one example and we can review the code together. This is a refinery operation application. The goal is to plan the operations of the refinery to maximize the total profits. This oil refinery purchases 2 crude oils, and then these crude oils are put through 4 processes: distillation, reforming, cracking, and blending to produce petrols and fuels, which are then sold. The VBA code for this model shows some of the many ways you can use the object-oriented API, such as how to call the solver and how to retrieve sensitivity information from VBA. To review the code, let's click on Developer tab and choose Visual Basic. Okay, now it is loaded for me. As you can see in the first line, with dim prop as new problem, we create an instance of the problem. I'm going to skip all the details, but here we are going to pick an engine, LP quadratic, and set its parameters. With problem.solver.optimize, you can run the optimization. In the next line, we are going to put a message box. You will see as we run it. And then down below it is a for loop, and within the for loop there is another message box. And then here down below with prop.solver.report, we are asking for an answer report, and you are going to see what happens when we run this. Now let me close this and click on this button to run the optimization. Okay, we start to get the results. Here are the values for decision variables. Let me go through this fast. And then you can see we get the results in message boxes. Let's quickly pass them through. Then we will start to get the dual values. Okay, it's finished. And as you can see here, our answer report is generated as we requested in the code. Okay. So you can access our optimization software within Analytics Solver Platform or Risk Solver Platform products, or get it as a standalone program such as Premium Solver Platform or Premium Solver Pro. Everything that we saw today can be done using Premium Solver Pro or more advanced products subject to your model size. The Solver upgrade products have very nice usability features with limits related to problem size, structures, and solver engines. The platform products allow you to add 8 different larger scale plugin solver engines that you can use to extend the power of these products. These make it practical to solve very large problems essentially only limited by memory. However, you can do much more with our products. We offer a complete solution for any type of conventional and stochastic optimization problem, simulation and risk analysis, decision trees, forecasting, data mining, and text mining. You can also find optimal solutions for models with uncertainty using chance constraints, recursive decision variables, and robust optimization and stochastic programming methods. Our wide-ranging product line empowers you to perform analytics on web and desktop spreadsheets, also web, server, and desktop applications in any scale. As we mentioned earlier, many of our customers have found optimal solutions for their industrial problems worth millions in savings. We saw today how building a model can give you insights as well as a money-saving optimal solution. Frontline Solver offers powerful tools to help you get a better solution by automatically diagnosing your model structure, fixing problems for you, selecting the solver engine, and providing updated information at each step. Today, we just explored one of these features, the guided mode, that helped us choose the right engine. Now, you might be asking, what is the next best step to begin? If you have not yet registered on our website, please register at our website. It's free. It allows you to access our downloadable user guides, more than 40 example models like the ones we have been showing here. Just click on Help and then Examples. Furthermore, it allows you to download a free trial at any time whenever you are ready. Try this yourself. After installation, go to those example models, and then during this trial period, you have full technical support. You can ask questions. Just give us a call. This is a specific number that is assigned for your questions today. 775-832-0123. And you can always reach me through consulting@solver.com with your questions. Thank you very much. Now it is time for questions and answers. So someone is one of our someone asked that if Solver can solve mixed integer problems. Yes, we have solver engines that can solve linear programming problems, linear programming mixed integer problems, nonlinear, convex, non-convex, and mixed integer nonlinears. And also we have engines that can solve your non-smooth problems. For example, evolutionary engine, you can use it for solving non-smooth problems. However, we want to have the best design, and we always try to have a linear model if possible. Yes, we have consulting services. If you have any consulting questions or concerns, just email me at consulting@solver.com and we can discuss it. We will make the recording available. We have a YouTube channel, Frontline Solvers YouTube channel, and we will post the recording there. Yes, the refinery model is available for download. Let me just show you how you can access this example one more time. So this is the ribbon. Let me see if you can see this. Okay, yes. Click on Help. Here you can click on Examples. It brings this workbook. And then you can access optimization examples from here. This gives you many examples. And refinery example is here. Transportation, everything we reviewed is available here for you to review later. Also, there are another set of optimization problems when you click on this optimization button, and you can go through them based on, for example, logistic examples, investment examples, and based on different application areas. And then Martin has a more detailed question. If you would kindly email me, I will send you more information. And another thing I wanted to point to here is just the user guides. So click on Help and User Guides, and then Main User Guide. And here you can access very detailed information about optimization and mastering optimization concepts. So if you're more interested to learn more about how to use our tools, this would be a very good reference for you. It has starting examples, and then conventional optimization, that's what you want to start with, and then it will go through mastering optimization concepts. This talks about automating your models in VBA, and then mastering conventional optimization concepts is for people who are interested to learn more about different structures and solution methods. Someone asked, how can you quickly go through the rows on the platform page? Okay, how do we get this Acrobat user guide? If you install a trial, go to click on Help and then User Guides. And then this is the main user guide. for like future references, we have reference guide, but I would recommend you starting with user guide, with building your first optimization model, and then for in-depth information you can refer to chapter Mastering Optimization Concepts. Yes, it is also available from our website, Martin. Yes, you can go to our website, and then you can, after registration, you can download these user guides. Yes. I wasn't sure what you meant with rows on the platform page. Do you mean here? So we have the model tab here, dimensional modeling options, and there's a chapter in user guide and lots of examples available, as I showed you. Defining your optimization model, you just select the cell, click on decisions to define as decision variables, then constraints, objective, parameters is used for defining parametric optimizations. This is for running your model. Then you can access different reports and charts. This publish button, you can publish this workbook for use with Excel Online and Google Sheets. The free app is called Solver. Just search for Solver and it's available. So you can share the model with your friend and with your colleagues over the web, and then different options, and then help tab. Oh, okay, this platform. So in the task pane, a platform tab, you can, the different options, for example, first one is number of optimization to run. And then we have like options for interpreter, and some of these are actually just being done automatically, so you don't really need to worry in the beginning. But if you have more detailed questions, just email me at consulting@solver.com. And some more advanced options, default bounds on your variables, and other things. Okay, thank you very much, everybody. I trust this webinar was helpful to you, and I really enjoyed presenting this. Looking forward to future webinars with you. We appreciate your time. Thank you very much. Bye for now.